Hi, so this session is our consolidation session. So taking some time with the learning that we've done so far, I'm going to be throwing things at you in a random order. I've done my best to find past exam questions, so we're really working on the real thing with this one. And yeah, it'll have the same feel as the last one. You'll have a go at a question and I will model how to answer it all the way through this session. All right, so press pause and hit play when you're ready. Okay, so this one is a nice, really kind of me. I know I'm lovely, really. You see, I gave you a nice, easy one to warm you up. A little old crab's claw. So y times y is y squared. Y times 5 is plus 5y. 2y is plus 2y. 2 times 5, 10. Everything's positive. Everything's nice and straightforward. Just be careful. Sometimes I think when it's easy and you can automatically kind of see it, you've got that confident with this type of thing, you could miss this step out. It is a 2-mark question. Really important that you show some method to get your method mark. Don't go straight to the answer or it's 1 mark. And we don't want to be losing marks, do we? Okay, so the next one is factorize. I've got 3 terms, so it'll be 2 brackets. Drop in the first term, do the signs. I've got pos neg, so it's pos neg, and then work on that 12. What multiplies to make 12 to give me 1? That will be 4 and 3. And I also want to make that a positive 1, meaning the 4 and 3 will go in that order. And then I'll just transfer to the answer. Okay, and I think for method-wise, that would be a really good thing to show the examiner. It's showing that you know exactly what you did. The next question we have in the question itself, give your solutions correct to 2 decimal places. So the first thing to note is the S here, solutions. That's telling you there's more than one answer. And correct to 2 decimal places is telling you that it's going to be the quadratic formula. It has to be. We don't do to 2 decimal places in factorizing, do we? So I'm going to write down what my A is. A is 3, B is equal to -1, C is equal to -1. I'm going to write down my actual formula, minus B plus or minus square root of B squared minus 4AC all over 2A. And then I'm going to populate the formula with the information. Remember, doing it step by step to avoid the errors that can happen so easily, so easily. So first thing in my formula is a minus. Then it's a B. I go up and B is -1. And that's exactly what I'm talking about. That is a really common place for people to go wrong. You don't have to have the bracket there. I like it there. So I've got minus B plus or minus square root of B squared. Now this is important. Putting that in brackets to avoid an error happening in the calculator is key there. -4 times 3 times -1, just extend that, all over 2 times 3. Okay, you should be working out those bits first. So that will then bring us down to having, where I can put it, I'll put it up here, 1 plus or minus square root of 13 all over 6. Okay, so this will split out into 1 plus root 13 over 6 and 1 minus root 13 over 6, giving us a final answer of 0.767 and on it went, and minus 0.434 and on it went. We've been asked to give our answer correct to 2 decimal places. So I've got X is equal to 0.77, careful with the rounding, and X is equal to minus 0.43. Okay, first question done. Next one. There you are. I'll clean this up so it's not distracting. So hit pause and press play when you're ready. Okay, so hopefully we could see this lends itself to simultaneous equations really, really clearly. It's not such a complicated question that we can't spot it fairly well. So I've got 3 teas plus 2 coffees equaling 7.8. Okay, I'm just going to use the numerical values, not worry about money whilst I'm doing my workings out. I've then got 5 teas plus 4 coffees equaling 14.2. I'm going to be multiplying this one by 5, this one by 3 in order to get that first term to match. That is going to give me 15t plus 10c equaling 39, and 15t plus 12c equaling 42.6. So we do our take away, take away, take away. So the t's have gone. 10c take away 12c is minus 2c. 39 take away 42.6 is minus 3.6. And when I divide through by that minus 2, I get c is equal to 1.8. So I could go straight up here and put £1.80 for my coffee. Do include the 0 at that stage because we want it to be correctly represented as money, don't we? Okay, so the last bit, I'm going to choose 3t plus 2c equaling 7.8. So that's going to give me 3t plus 2 1.8s, which is 3.6. And then going to obviously take that off, giving me 3t equals 4.2. Divide through by the 3, and t comes out at 1.4. So t is £1.40. And if you got that right, fab work, well done. Really nice. Okay, there's your next question. Hit play when you're ready. Okay, so I've clocked its perpendicular, not parallel, which means that my m here in the equation they've given me is 1/4. So my perpendicular m is going to be opposite sign, flipped reciprocal 4, and that will be the m that I need to use in my formula. I've been given the coordinates, so I'll label that up x1, y1. So it is y minus y1 equals mx minus x1. Then I start populating with the information. Oops, obviously hit something by accident there. Made it bigger than I need to. Sorry about that. There we go, try again. Okay, so now I'm going to start populating. So y1 is 5, so minus 5. M is minus 4, x minus, and x1 is 8. So I've got y minus 5 equaling minus 4x. 4 times 8 is 32. And obviously the 2 negatives make that positive. I want to get rid of that minus. So it's going to land as plus 5. Y is now on its own. Minus 4x plus 37. And if you got that right, fabulous. Really well done. Okay. And we have our first circle theorem. Are we going to see the whole thing? We are. There we go. So, as always, just take your time, take in all the information, look your way around that diagram, and then start the process of solving. Hit play when you're ready. Okay, so when I read this question, it says work out the size of angle DAC. So they've not actually marked that on with an X. So I am going to do that myself so that I've got a clear vision of where I'm trying to go. So DAC, there's the D, going to the A, going to the C is this angle here. So I'm going to mark that one on as my missing angle. And then I'm going to see where the lines that made that angle, where they actually go to on the circumference, because that could be really key to solving this. So we're going to go there. That means, and again, I know it gets quite colourful, but hopefully it won't get too messy. That means that these 2 points come off the circumference to make X. So if there's another 2 lines from those points that hit the circumference in the same segment, they're going to be the same. So when I look at that, I can go off in this direction, hit the circumference, and this direction and hit the circumference. And that means that that is X as well. So I don't know what it is yet, but I know that those 2 angles in that diagram are equal. So that was kind of like the first thought that I had. The next thing that I really spotted, if you like, I kind of spotted both these things at the same time, and it wouldn't matter which way round I did it. I've obviously got the diameter, and an angle that goes up and hits the circumference from a diameter is always 90 degrees. So I know I have a 90-degree angle in there as well. So X plus another angle would equal 90. That's what I can see in the diagram there. And then as far as the theorems go, that's probably it. They have given me 25 and they have given me 100. Now that 100 is a really easy one for me to start working with because I've got opposite angles that equal here. So I can go straight in with E being 100 degrees. Okay. Now it says that I've got to work out DAC and I must show all my working. It doesn't say I have to give reasons, so I can kind of relax with the writing of the sentences. So I've got my 100 degrees. I use vertically opposite. I don't need to write that down. I can now find this triangle because I've got 2 angles. So there it is. So I'm going to be doing 180. Take away 125, that'll give me 55. So I know this side here is 55. Always mark on your diagram. It's really helpful to keep an eye on what's going on. That's exactly the angle I need to use with that 90 degree, isn't it? So now I can do 90, take away 55. That's going to give me 35, which is X. X is 35. If that angle there is 35, that angle there is 35. And that was the one they wanted us to find. Okay. So if you got that, well done, really well done. If you're not getting these, don't panic. You've got plenty of time to keep practicing, plenty of time to keep securing and growing in confidence. Remember, this is recorded. You could come back to this in a couple of weeks and have another go. So it's all good. All good. So if it's going well, that feels great. If it's not going well, that can sometimes feel a bit demoralizing. Don't let it. Just keep reminding yourself you're a learner. You're here trying to get better. If you were the finished article that could do everything really easily, I probably wouldn't be talking to you because you probably wouldn't have signed up for the course. So always keep it in perspective and always stay positive. Okay. Right. Next question. Get it up so we can see it nice and clearly. Hit pause and press play when you're ready. All right, so what have we got here? 2 cylinders, A and B, are mathematically similar. So there's that key word, similar. So that tells me that it's scale factor squared, scale factor cubed. Okay, which obviously is my volume, my area, and my length. Okay, so just that word takes me straight there. Okay, the height of B is twice the corresponding height of A. Now, when you first read that, it kind of feels like you haven't got enough information because you don't know what the height is. But in reality, you don't really need to know. If the height is X, then the height of B is 2X. The scale factor is going to be times by 2. You know, I could have put the number 5. If I times that by 2, it would be 10. So I could do it numerically to also test that out. So the scale factor is 2. It says the volume of A is 13 centimeters cubed. So the volume here is 13 centimeters cubed. And that is another thing that I would do. There is a nice diagram, but they haven't put anything on it. So take the information and get it onto your diagram, okay? And now, hopefully, it's all fairly straightforward from here. I know that the volume of A is multiplied by the scale factor cubed to equal the volume of B. The volume of A is 13. The scale factor is 2 cubed, which is basically going to be 8. And 13 times 8 is 104. So B is 104 centimeters cubed. All right, well done if you got that right. Okay, next question. We've got hit play when you're ready. Okay, now there is no word similar here, but all circles are similar, so they don't really need to, okay? The area of circle S is 4 centimeters. So the area here is 4 centimeters squared. The radius of T is 3 times the radius of S. So I've got my radius, and this is 3 times the radius of S. So I've got a scale factor here of 3, working in the same way that that last question did. Then I've got to work out the area of T. So the area of the small times by scale factor squared, because it's an area question, is equal to the bigger circle. So I've got 4 times 3 squared, which is basically 4 times 9, which is 36 centimeters squared. Okay, so if you got that right, well done. And moving swiftly on. Okay, so again, what I want you to do is to not worry about how the fact this looks very different to anything you've done before. You know your GCSE is going to do this to you, so we want to be prepared and not put off by it. All I want you to do is continually be thinking about the keywords, what they mean, what you know about it, how you can use it, and just try every idea that comes to you. And then when you're ready, hit play. Okay, so the diagram shows a right-angled triangle and all the measures are in centimeters. The area of the triangle is 27.5, and we've got to work out the length of the shortest side of the triangle. Now, for me to be able to work out the length of the shortest side, I would need to know what X is. So that's my main problem, to work out what X is. The only thing that they've really given me to help is this sentence here. I know for a fact that the area of a triangle is 27.5. What do I know about the area of a triangle? I know that to find the area of a triangle, I do base times height divided by 2. I know that the base times the height divided by 2 is going to equal 27.5. So what is the base? This is like being rotated, okay? So the base is kind of looking like the top. Remember that the base and the height are always pointed to by the right angle. So if they twist a triangle and it helps you kind of just lose track a little bit of where the base and the height is, then use the right angle to point at the 2 edges. So equally, they've only labeled 2 edges. So I haven't got much choice, have I, but to use those. So the base, X plus 4, has to be multiplied. So all of that has to be multiplied to the height, X minus 2. Okay. And then it's divided by 2. And that will equal 27.5. So I haven't done a massive amount really. I've just remembered it's base times height divided by 2, and I've just taken the information from the diagram and I've put it into the formula. Now the kind of number crunching starts and all the skills start. I'm going to get rid of that divide first of all. You can go over there, land as a times, and then that's going to give me X plus, whoops, don't want to put the bracket in yet, X plus 4 x minus 2 equaling 55. I'm going to crab's claw this out because I can see it's a quadratic, but it isn't a quadratic that equals 0. So it's not like I can just go on and say, oh, x is minus 4 and x is 2. I can't solve it. It doesn't equal 0. As soon as I bring that 55 across, then it's like this random thing that's going with the bracket. So I'm going to expand the bracket first to give me x squared minus 2x plus 4x, and then minus 8. I'm also going to bring the 55 across, which would land as minus 55, so that I can get it to equal 0. So I've done all of that so far. When that all tidies up, let's get some more space. When that all tidies up, I'm going to have x squared minus 2x plus 4x is plus 2x. And minus 8 minus 55 is minus 63. That's going to equal 0. So I've got 3 terms, 2 brackets, x, pos, neg. 63 is made by doing 9 and 7. I want a positive 2, so the 9 will go there. And my solutions are x is equal to minus 9 or x is equal to 7. Now, this context, this story is about the length of an edge of a triangle. I can't take or have a negative edge. So if I was to say x is equal to minus 9, oops, put the minus in, minus 9 minus 2 is minus 11. Yeah, if I did x minus 2, I'd have minus 9 minus 2 equals minus 11. That can't be true. So that is not relevant to this question. The x equaling minus 9 is a solution, but it isn't a relevant solution to my problem. I need the x equals 7 because 7 minus 2 will give me 5. 5 is a positive number, which means it can be an edge, and that is the answer to this question. So this is solving quadratics. It's what we've been practicing, but it's all wrapped up and hidden in a question, forcing you to kind of pull it out, which is tough. It's not an easy thing to do. If you got that right, then absolutely incredible. Well done, because it's the first time we've seen anything really that tricky with our quadratic problem solving. If you kind of got halfway there, great. If you've listened through to how it works and you're sort of sitting there thinking, oh, I can see that now, then that's really good. So we're going to try and bring a little bit more of this in as we proceed with the course and in the consolidations at the end, so that you just get a bit more exposed to it. All right, next question is this one, and I'd like you to hit that pause button and press play when you've done your very best with it. Okay, this feels hard. It really does feel hard. It'd be a question quite near the end of the paper, which is when we are in that zone of, oh my God, I can't answer anymore. You always can. Okay, let's just read through. We've got a rhombus. The coordinates of A are 5, 11. The equation of the diagonal DB is given to us as a half x plus 6. I think something got lost in the transfer of the question, maybe. So let's look at the diagonal and just pop that on. So my diagonal is DB, which goes off in that direction. And the coordinates of A were given to us. I'm just going to color that corner in just so that I know it's that one there. I've got to find an equation of the diagonal AC. So I'll just draw that one in. They're a bit wibbly wobbly. If I'd drawn a straight line, it would be easier to see that the diagonals of a rhombus cut at right angles. So these two diagonals are perpendicular. So this is a perpendicular question without using the word perpendicular anywhere. Okay. But once you realize that, actually the steps are no different at all from just the basic sentenced style question. Okay, so I've been given in my equation a half x. So the diagonal DB has m equals a half. So our perpendicular is going to be opposite sign, flipped. It's going to be -2. So that's the m that I need. The coordinates 5, 11, which are up here, are on the line. Okay, so that's my x and my y value. So I might just pop that down as well. So I've got 5, 11, that's my x1, that's my y1. So now it's y minus y1 equals x. Goodness me. Let's try that again. M, x minus x1. So y minus 11 equals -2x minus 5. Y minus 11 equals -2x. 2 negatives make a positive. 2 times 5 is 10. Get y on its own. So -11 is coming across. Landing is +11. And then my final answer, which I'm going to put on the dotted line, is y equals -2x plus 21. Okay. So the basic skills of finding parallel and perpendicular lines could be classed as grade 6. But a question like that is going to be, again, it's going to be classed as grade 7, 8. It's near the end of the booklet. It's high level because they've tried to hide the work in the diagram. So yes, there is a skill in pulling it out and recognizing it's in there. But once you realize that, the actual maths, the actual process isn't any different. There is nothing in addition to our basic style question than this one. Everything here is what we've learnt. And now you're accessing much harder questions, and you're doing it because of this beautiful magic formula here. Really, really good formula to just use as soon as you need to. Just introduce it early. That's what I say. Okay. We got a nice little circle theorem as our next question. Let's pull it up so we can see the whole thing. There we go. Hit that pause button and press play when you're ready. Okay, so again, it's always about digesting everything that you've got in the actual diagram along with the information that they give you as well. I know I've got a center of the circle. S and T are points on the circumference. I can see that. We've got that straight line. Angle OPT is marked on for me at 32, and I need to work out the size of the angle marked X. So everything is in the diagram already. There isn't anything in the extra worded version that needs to get transferred up. So it's just a case of me now starting to go through all those properties that I've learnt so that I can go on and solve this. It says work out the size of the angle marked X, but it does also say give reasons for your answer. So we want to be doing that as we go. This is a 5-mark question, and if our reasoning isn't there, we are losing easily half of them, if not 3 out of the 5. So really important that we do it as we go, I think. So the first thing that I'm going to mark on is this right angle here. I know that a tangent to a radius is equal to 90 degrees. Therefore, angle P, I keep writing down what I'm about to say rather than writing down what I want to say. Angle PTO is equal to 90 degrees for that reason. Okay, marked on my diagram. I am now able to find angle PT, POT, pot. So POT is going to equal 180, take away my 90 plus 32. Okay, that's going to equal 58. And the reason for that is triangles equal 180 degrees. So I've written my reason for that piece of maths and I've worked out that that is 58. I can now do TOS, which is going to be 180 minus 58, which is 122. And I've used my straight line equals 180 degrees. Going to mark that one on. And then I can see that we've got an isosceles triangle, which has been made by the two radii. So I am going to be able to now do x is equal to 180, take away 122, which is 58 again. You can see we're going between these numbers a bit, aren't we? Divide that through by 2, and I've got 29 degrees as my final answer. And don't forget on that last step to write down isos triangle equals 180 degrees. Now I've written my reasoning in real shorthand just because I want to try and squeeze it all on the page for you to be able to see everything. If I was doing this as an actual GCSE exam, I would be writing it out really well, really good sentences so that I am not risking the loss of any marks. So when you look at that, this was from a past paper that was 5 marks. Nothing there was too complicated. Most commonly when I see this, people just don't write their reasons down. They get so, I think, engrossed in the problem solving of the angles themselves, they forget to write the reasoning. So I stress that, as you can tell. Okay, we have another one. So this is a 3-mark question. I want you to press pause and hit play when you're ready. Okay. So S&T are points on a circumference. I've got center O. So I know just from that sentence that we've got a radius going to the T and going to the S. PT and PS are tangents. So I know straight away that they are making right angles. It says angle TPO. Trace it out. TPO is off in that direction. So I'm going to actually add in that line. Marking TPO is 24. And they want me to work out the size of angle SOT. So they want this angle here. So I could just work out this one and double it, couldn't I? I could work it out as a quadrilateral. As with all circle theorems and all angle problems, there's usually more than one way. The previous one that we just did, there probably was more than one way. You may have done it a different way. Remember what I've said in the past about that. If you've got the right answer and all the evidence to back up your steps, then it's absolutely fine. It doesn't have to be the same way as me for it to be a right answer. Okay, I'm going to do the 360, I think. So I'm going to say I've got a kite, a quadrilateral. I'm going to do 360. I'm going to take away the 2 90s, which is obviously 180. I'm going to take away, there's another 24 there. So I'm going to take away 48. And that is going to give me 132 degrees, which is my answer. Nowhere does it ask me to give reasons, so I haven't done that. All right, so if you've got 132, then super duper. Okay, next question. We are going to solve by factorizing. Now you do have to factorize because they've said solve by factorizing, but it did come from a calculator paper. So you've got a calculator that can help you with this. Okay, so first step is to multiply the 8 and the 27. That is going to give us 216. So 216 is going to be the number that we do our split with. I'm also going to set up my brackets. So I've got 8x and 8x at the front. It's neg, so it's going to become neg pos. But it might equal 0 as well. I'm then going to use my calculator to help me find the two factors that multiply to make 216, but will also help me make 30. That is 6 and 36. I want to make negative 30. So 36 would go in here and 6 would go in here. Minus 36 plus 6 is minus 30. So that works a treat. Now I need to cancel this down. So we're going to divide this one by 4, which is going to give me 2x minus 9. We're going to divide this one as well, because they're both even. So I can divide by 2 to give me 4x plus 3. I do a quick check at this stage. 2x times 4x is 8x squared, which is what I want it to be. So that's good. Minus 9 times 3 is minus 27, which is what I've got. So looks like I have done everything right. So now I just need to, well, I don't even need to go on and solve it. It just says, oh, it does say solve by factorizing. What am I talking about? So this one is going to be x equals opposite side 9/2. And this is going to be x equals opposite sign 3/4. And don't even bother changing it to decimals or anything. You really don't need to, okay? So x is 9/2 or x is minus 3/4. And you, like I say, you don't need to show it as decimals or anything like that. Top heavy fractions are fine. Don't need to go to mixed numbers. Okay, next question. All right. Shape G is similar to shape H. The area of G is 210 centimeters squared. And you've got to calculate the area of H. Press play when you're ready. Okay, so the smaller times by the scale factor makes the bigger. The smaller is 6. The scale factor is what I want, and it's 10.6. Okay, going to divide through by that 6 so that the scale factor is on its own. Scale factor, if I do this in the calculator, it gives me 1.76666 and so on. So remember what I've said about this. Don't use a decimal version if it's not a simple decimal. If you round at this stage, you will get an inaccurate answer. You can only round at the very end. So we're going to have to stay with our scale factor looking like a fraction. 10.6/6 is our scale factor, okay? So this is about area. So it's going to be scale factor squared. So I've got my small, which will be times by my scale factor squared to make my big. My small is what I don't know, times by my scale factor, which is 10.6/6, all squared. And that would equal G, which is 210. I'm going to be moving all of this to the other side. The times will change to a divide. So I've got S is equal to 210 divided by 10.6/6, all squared. And when I pop that into the calculator, I will get 67.283, and I will round to however the question tells me to round. All right, so hopefully that one went well. Do we have any more on this page? Nope. So next page, I want you to hit pause and press play when you're ready. Okay, so again, the giveaway here is this correct to 2 decimal places. No point in even wasting my time trying to factorize that because it's 2 decimal places. So my A is equal to 3. B is equal to 6, C is equal to minus 2. It's minus B plus or minus square root of B squared minus 4AC all over 2A. Put in everything carefully. Minus B is 6 plus or minus 6 squared minus 4 times 3 times minus 2 all over 2 times 3. So this is going to give me minus 6 plus or minus root 60 all over 6, which will split to minus 6 plus root 60 over 6 and minus 6 minus root 60 over 6. And that goes on to give me 0.290 and minus 2.290. These did go on. We want correct 2 decimal places. So x is equal to 0.29 or x is equal to minus 2.29. Okay, hopefully that quadratic formula is working a treat for you. All right, next question. We have another circle theorem. All right, so press pause and hit play when you're ready. Okay, so A, B, and C are points on a circle. The radius is 5. We've got the center point as well. DA and DC are tangents to the circle. DO is 9. So DO is 9 and it's not actually been written on. So that's the first thing I'm going to do. That is 9 centimeters. Also, the DA and the DC are tangents to the circle. So it makes sense to mark that in as well. They want me to work out the length of the arc ABC. Okay. So the length of the arc ABC, I'm going to highlight it, is that bit there. Okay, so what are we going to do first? Okay, so we've done everything we need to do with the circle theorems. This is now going to move into some of a different area of maths that we haven't really covered in the grade 6, but they are grade 5 skills. Now the problem solving is quite a big deal. There's a lot happening, but there shouldn't be any maths that I'm about to show you that you haven't already seen, okay? So what I need to do is I need to find this angle here. Now I've got a right angle triangle and I want to find a missing angle. So this is trigonometry. This is SOHCAHTOA. So when I look at this, okay, 9 centimeters, that's my hypotenuse there. Okay, opposite is always opposite the angle. So that's over here, which means this edge here is my adjacent. I've got A and H. So I'm going to be using cos theta equals A over H. So cos theta is equal to A, which is 5, over H, which is 9. If I want to know what the angle equals, I've got to get it on its own. So cos is going to go across. It will land as cos minus 1. So I've got theta equaling cos minus 1, 5 over 9. Pop that in your calculator and you get 56.25101. On and on it goes. Just leave it on the calculator screen. Remember, you can't round, so you're going to leave it there. We're then going to double it so that we can have the whole of this angle here. So I'm going to times by 2, and that's going to give me 112.502. And on it goes. Okay. What I'm actually after is this angle here. I want a fraction of the circumference. Okay, so I need to know the angle here so I know what fraction of the circumference I actually want. So I'm now going to do 360, take away 112.5020. Remember, that's on my screen already. So all I've got to do is 360, take away answer. I haven't got to type all that in. 360, take away the answer. That is then going to give me 247.49, and on it goes. Okay, let's take that up a little bit. So we've got some room over here. So I'm going to take the 247.49, on it goes, and set it up over 360. When I find the circumference of a circle, okay, I'm going to use the formula pi d. So C is equal to pi d. When I do pi d, it gives me all of the circumference. But I actually only want a part of it. I just want a fraction of it. I want 247.49 degrees out of the 360 degrees. So that's what that fraction is doing. If I times that to my pi d, so pi times, and the diameter is 10. The radius is 5, so my diameter is 10. When I throw that into my calculator, I get 21.5982, on it goes, to give me a final answer of 21.6 centimeters. So that was well, it was a mean question, basically. So I'm sorry. If you managed to get somewhere with that, then really well done. If you kind of got stuck on the first hurdle, it's just because you weren't expecting any of that. And what we end up doing is we end up getting into a comfort zone, and we just think of circle theorems is about the properties we've learned and how to apply them in questions that look like that. And we start to expect that to the point where we block out every other piece of knowledge that we've got. So when you've been going through all your theorems and you've been trying to work out how this is going to come together, and you just keep hitting blank after blank after blank, something more must be going on. And they can bring trig in. If there's a right angle triangle, they can be bringing in trig, they can bring it in Pythag. They wanted part of a circumference. There's circles there, so why can't there be pi d and pi r squared as part of our problem solving? So really that was just, again, to just jolt us out of our comfort zone. Okay, not an expectation that the next time you see that, you're just going to be awesome. You've seen it once, but it's more about be ready, be aware that they are going to create a situation that you may not have seen before. All right. I hope that's useful to see and not just off-putting. Okay, here is your next question. You've got to find the total area of that pattern, okay? So I want you to hit that pause button and press play when you're ready. Okay, so I hope that we spotted the sneaky little simultaneous equation. Admittedly, you can problem solve this without it, but it's so simple and straightforward to do. So the area of the pattern is basically a pattern that's made up of rectangles. Rectangles have a width and a length, or a base and a height, however you choose to do it. When I look along the top here, I've got 2 lengths and a width. So I've got 2 lengths plus a width equaling 11. When I look down the side, I've just got 1 length and 1 width. So I've got a length plus a width equaling 7. Now I like the front to match, as you know, and there was no reason for me to write the length first. I could have written the width first, and if I had, they'd have matched straight away. So I'm actually just going to rewrite that to suit what I want it to do. So I've got the width plus 2 lengths equaling 11, and I've got the width plus a length equaling 7. I can now just go straight into my takeaway, which is going to give me L equals 4. I can then use length plus width equaling 7. The length is 4 plus whatever the width is. So the width must be 3. So I now know the width is 3 the length is 4. 4 times 3 is 12. I've got 4 of those rectangles, so 4 times 12 is 48, and I've got 48 centimeters squared. Now, the mark scheme is all about the simultaneous equations because it is embedded in the problem. If you problem solved your way in a completely separate way, but got to that final answer, I can't promise you would get full marks because there was an expectation of simultaneous equations. So you might drop 1, but if you've got, like I say, if you've got all the maths to evidence how you got to your 48, and it's absolutely, there's no assumptions, you haven't assumed anything, then there's no reason why you won't get full marks, okay? And obviously the reason for that question is don't always expect simultaneous equations to be, to be coming from worded questions like tea and coffee. They can come from a geometrical shape as well. Okay, I think we've got one more and then you are off the hook, okay? So a nice one, I hope, to finish up on. Take your time with it. Remember what everything needs to be like in order to be able to use it, and hit play when you're ready. Okay, so I can see that this is writing the equation of a line that's perpendicular. So I've got everything there, nothing's hidden. I know that it's going to be my y minus y1 equals mx minus x1 formula. But my problem actually starts here. I don't have this in my y equals mx plus c general form. So I'm going to have to do a little bit of rearranging with this. So let's do that first of all. So I've got 4x minus 2y equaling 6. Now I need my y not only to be on its own, so I've got to get rid of that too, but I don't want a negative either. So what I'm going to do, which is just taking a shortcut really, I'm going to actually move the minus 2y over there so that it becomes positive 2y. And I'm going to move the 6 over here so that I've got 4x take 6 equaling 2y. And then I can divide through by that 2 to give me a final answer of 2x minus 3 equals y, which I can rewrite the other way if I prefer to see it like that. I don't really have to or need to, but I can. All right. So that was really the tricky bit with this question. Now that I've got it in the right form, I can see easily that the m is equal to 2. So my perpendicular m is going to be opposite sign, reciprocal, that flipped version. My x1 and my y1 are there in the question. So now I have everything I need to carry on with my formula here. So y minus, and I've got a minus 2 equals minus a half x minus 8. This is obviously going to give me plus 2. I've got minus a half x, and then the two negatives make a positive. Half of 8 is 4. Got to get that y on its own, so that's going to land as minus 2. And I've got y equals minus a half x plus 2. And if you got that right, really, really good. I do just want to show you one thing before we sign off this session. Sometimes you might see in textbooks that this could have been written as y equals minus x over 2 plus 2, which feels very different. And if you're not sure how or why that is equivalent, I thought I'd just share that little detail with you now. It doesn't matter which way round you do it. I think physically seeing the number makes things feel easier, but it doesn't matter. That's the thing. So this bit here, which we had in our answer, is a minus half squashed up to an x, which we know means times. X is a number I don't know. All right, if I was to put it over 1 so that it looked like a fraction and then used my fraction rules, I'd have 1 times x is x on the top, 2 times 1 is 2 on the bottom. I've got 1 negative in the question, so there's 1 in the answer. And that's how you can take this minus half x and make it look or be represented like that. It is the exact same thing. And it doesn't matter which way you do it, like I said. All right, so that was quite a big session, a few nasty little surprises in there for you, which I am sorry about, I promise. I don't really do it to upset you, but it's really important that we are just seeing the type of things that can happen to us. Just when we think we're getting it, something comes along and kind of messes things up a bit. They love crossing over topics in higher. So it is something that we do want to get really aware of so that we can really look for it. Anyway, that is it for today. Really, really well done. And I will see you next session.